Ignition sequence start. 3, 2, 1.
Houston, we have a problem.
Liftoff. We have a liftoff.
We copy you on the ground. You got a bunch of guys about to turn blue.
What you're seeing here is a mirage.
What's going on, everyone? It's Jeranism, back with another live video for you today, this evening, this afternoon, whatever it is, wherever you're at. Going to keep this relatively short, at least I hope so. I have Raw on True Frequency Radio at 6 p.m. Pacific time, and as Raw continues to be the #1 show on TFR on Monday nights between 6 and 9 Pacific and 9 and midnight Eastern. So thanks for joining me. I do appreciate it. I know you guys have lots of places you can be, lots of shows you could be watching, so the fact that you've chose me is pretty awesome, and it's exceptionally intelligent, too, if you really think about it. But no, it's really awesome. So thank you to those in the chat. I appreciate it. Those at home in your car. Those upside down in Australia, and those perpendicular over in Mozambique. Thank you guys for joining me. So what we're going to do today is a few things, and trying to keep them all short. But first, I did want to talk a little bit about Voyager. If you haven't seen it yet, there is actually I guess you can call it a movie. It's over at everybody's favorite public broadcasting system, PBS. And the name of the program is, I'm trying to get this up for you so you can see it, but for some reason I don't see it. Oh, there it is. The name is it's called The Furthest, and you would think it's some sort of parody. That's how actually truly bad it is. But we're going to watch a little bit of it, and hopefully you can hear it, and I think you should be able to. I don't think there'll be any problems. And we're just going to watch mostly the beginning. I think there's some interesting points. Basically, they're going to be interviewing these scientists. And remember, if you don't know what Voyager is, Voyager 1 and Voyager 2 are two spacecraft that were basically sent out in 1977. We're going to learn about them here in a second when we get into this video, so you'll learn a little bit. But it's just hilarious to think that as of today, NASA claims to be in communication with both Voyager 1 and Voyager 2. And if you want to know where it currently is, I'm going to look into that real quick. I think it's 13 billion, but I will find out for you right now. Let's go Voyager 1 distance. I think there is some websites set up that calculate for you the exact amount. Where are we at here? Let's see, Voyager mission facts, fast facts. Looks like 10.8 billion miles from the sun. So, if you believe that, hey, more power to you. It just is, it doesn't make any logical sense. It is completely and totally against everything we see in reality, everything we see around the world. If we think that there's magic Wi-Fi that travels through space 13 or 10 or 11 billion miles, if you think that it travels 1 million miles, I'd have questions with that. So when we get to be orders of magnitude greater, I think we need to call into question these people who say that that's what's going on. And again, what we'll see here too, as we watch this video as it begins, these scientists that are very intelligent people, not putting that by them. I'm not trying to say that they're not intelligent. The problem is that they are heavily indoctrinated into the idea that these satellites that they built, they actually used their hands and built these crafts, and they handed them off to NASA, who then shoots a rocket and makes the ground shake and makes fire go boom. And then anything that happens after that, it's like the people have lost all faculty to recognize the possibility of deception. And when you're looking for the truth, when you're looking for proof of satellites, of these spacecraft, thank you for joining me, you quickly learn that that's where it's missing, because these people do not have video camera feeds to watch their spacecraft as it flies through space. They have tones. Different tones are played at different times, and this tells them that the craft is where it's supposed to be, it's on track, it's on schedule, its temperatures are correct. But as we watch this little film here, I think we'll get a different idea. So I'm going to start playing it, and if you guys don't hear it, somebody in the chat, please let me know. Or if you can hear it, just say yes, we can hear it. And the video is starting now.
It is really true that you can only explore the solar system for the first time once. Voyager did that.
How could one be so lucky? It's a dream, and it came true.
50 years from now, Voyager will be the science project of the 20th century. The mission, the big mission.
It opened our eyes to worlds, to real worlds.
This may, in the long run, be the only evidence that we ever existed.
So I will be pausing it at opportune times like that. What does that mean? This will be the only evidence that we ever existed. The Voyager 1 and Voyager 2 spacecraft. That's the only evidence.
Voyager to me was Homeric. It was years of passing across the solar system from one planet to the other, and then it was a week or two of frenzied activity and discovery and conquest, and then it was, well, back in the boats, oars in the water, and then on to the next conquest.
I'm wishing on a star to follow where you are.
Wishing on a dream of it.
I'm wishing on a dream.
It is the little engine that could. Nobody really knows how it does it, but everybody's rooting for it.
Nobody really knows how it does it, but everybody's rooting for it. So nobody really knows how the thing communicates or anything. I don't know that. But it does it. So shut your mouths.
And I wish on all the rainbows that I see.
Every second, it goes to another place where we have never been before.
Voyager takes the cake. It's the most audacious mission.
For most CGI in a movie, 2017?
Who'd have thought that we'd actually be able to do that?
Not me.
Voyager takes the cake. It's the most audacious mission. Who'd have thought that we'd actually be able to do that in 1977?
All right, so this next part, very interesting. This is a mainstream astronomer, but pay close attention to what is said here.
In 1977, a team of scientists and engineers launched a mission of staggering ambition, Voyager. The initial idea was a grand tour of the outermost planets, Jupiter, Saturn, Uranus, and Neptune. What were their atmospheres like? Their moons? At the time, our knowledge of these worlds was scant.
We knew a little, because you can't observe from the Earth with telescopes.
We knew, for example, at Jupiter that there were moons, Io, Europa, Ganymede, and Callisto going around.
We knew that there were winds on Jupiter. We knew about the Great Red Spot on Jupiter. We knew that there was trapped radiation, so we knew there was a magnetic field.
It was big. No, let's see, what did we know? We knew they were all gas giants, mostly made up of hydrogen and helium and some methane on the outer.
So let's just think of that real quick. That, you know, these planets that they've... He says we know that they're just gas planets. Gas planets. They're gas. Think of what gas is. Gas planets. Jupiter, it's a big ball of gas. Who cares? Let's continue.
Planets.
For Saturn, we knew about the rings and we knew about the major satellites.
but hardly anything more than that. And it was all very fuzzy.
Okay, listen right here. The greatest line of the video or the movie.
I had been staring at these planets through some of the best telescopes on Earth, and yet all I could see was fuzzy blobs.
All right, so just make sure you heard that. Maybe we can rewind that just one more chance and hear that again for all the people who say they see all these planets in their telescopes. At home, they see spheres. They see the spherical planets all over. Let's listen again.
All gas giants,
Somebody who works
mostly
for
made
NASA,
up of
by the
hydrogen and helium and some methane on the outer planets.
For Saturn, we knew about the rings and we knew about the major satellites, but hardly anything more than that. And it was all very fuzzy.
I had been staring at these planets through some of the best telescopes on Earth, and yet all I could see was fuzzy blobs.
Astronomers had worked pretty hard to know what physical makeup was. There were some basic characteristics, but their real nature, what they were really made of, and what the moons were like, we had none of that, just little glimpses.
So they had no idea what these outer planets are like. Mars, Jupiter, Saturn, Uranus, they had no idea. Astronomers, people that everyone think are so smart because they've spent all their time studying about these things, but they didn't know until NASA in 1977 sent out a spacecraft or two, and it was just the right time. We're going to find out here shortly. The timing was perfect because they were able to get gravity kicks, which have been disproven many times over. But they get gravity kicks, so it'll go out and it'll like go around Jupiter, and then it will get some gravity boost so that it can go around Saturn, and then it gets a gravity boost, and then it can go. Nonsense. So funny. All right, let's continue.
Human beings are a curious bunch. We want to know what's around the corner. We have to go past that next bend in the road. So it's...
See, this is the principle, just see if you don't understand why they do what they do. Why does NASA lie? Why does many people in the world go along with it? Because they're under this faulty assumption that if we knew we had nowhere to go, if we knew that we were perhaps enclosed, if we knew perhaps that there was no outer reaches, maybe there was new areas we could go to on the plane, whatever it might be, or there may not be no new places. But regardless, they take this idea of space and they say that the reason why we have come so far technologically, the reason why we've come so far as a civilization, they all bank it on this idea of filling children's heads with balls, with the idea of spheres and the idea of endless space. But they're handicapped because in order for their model to work, these places need to be unreachable. And this is the lie of astronomy today that is such a joke, because none of these stars will ever be reached by humans unless you employ time warps and Einstein, Rosenthal bridges, and you name it. But that is what they're doing, is and you've heard them talk about it before. They talk about how America propelled itself to be the great capitalistic country that it is because of the moon race, and that pulling everybody's skills together and accomplishing a goal that it set out to accomplish made America the great country it is. This is the reason that they can't go back and tell the truth about Apollo, because they know that there's too many people in this country that have banked their entire sense of self-pride around the fact that other men supposedly went to the moon. That's how pathetic it has become. That's a sense of pride for people. And I see it as a sense of disappointment that call them your ancestors, your grandparents, whatever, were blatantly lied to. But at a certain point, you just need to be honest with people. You can't keep going with this lie, and it's an obvious lie, because NASA exists only because of Apollo. If you really look at the past and what NASA has done, they built a helium balloon airplane, called it a shuttle. They do basically nothing. They charge money to the public to go to their little space centers around the United States, which was paid for by the same people who are paying admission to the space parks. They charge you back for the research that you did. You paid money for them to do research. They found things, then they got patents for it, then they sold the patents to businesses. And then those businesses turn around and charge you money for what you buy. It is all a scam against those who lay at the bottom of the pyramid. Turn your dollar bill over, take a look at what's on the back of it, and know our place. Where are we? Are we at the top of that pyramid? Are we the ones stepping on others and extorting and cheating our way through lives? No. We're the ones who have to take the brunt of it, and then we get put in this awkward situation of having to come up with a new model, being challenged on it, being told we're idiots for doubting the current mainstream, when to those who are awake, to those who have eyes to see, ears to hear, it is patently obvious, it's absurd that anybody can't see that there is no proof of space travel. It is a great dream that we all fell for. Every one of us. There's not one of us here who can say, I never fell for it. I'm so smart, I never fell for it. I've never met one person that's even dared say that, because it's not possible in the world. And so the fact that we're able to come out of that and see it now is pretty impressive. But we also, and if you ask any of us, I maybe not, but for me, once you got the opportunity to consider the facts and the evidence, then it wasn't difficult. And I think I've had so many emails and people who have said that the difficult part is getting to that point of research. And that's why I released a video, I think it was today, might have been yesterday, called Research Flat Earth. Just a short little video clip, but I also attached 2 files in the description and in the comments. Just some flyers that Missa has been taking around with us. And by the way, sorry if you missed us last week. We were busy with book stuff. We had to go down to El Cajon last Monday, and we thought we'd actually go down there, pick up we won an auction for some stuff, and we'd be back in time for our show at 6 p.m. So we left at 2 a.m. But things did not go as planned. It was very foggy the whole way down, and we were stuck in LA traffic, so ended up being about a 10-hour drive down, about an hour to load everything that we won at the auction, and then a nice 9-hour drive back. So it was a exciting day. And then this week we've been getting all that stuff ready to sell. Got a ton of good books, Karl Marx books, all this stuff. It looks like a person's estate. And yeah, so we do good at those auctions because booksellers don't usually go to those. They look for book auctions. This one we just happen to get a steal. But also, if anybody speaks German and has any interest in some Nietzsche books, I have some books that we picked up down there, great ones. They're about, they retail for like $300 a piece. And I've got probably 20 of them. So unfortunately, when you run a bookstore like we do, we don't have the kind of inventory we can just sit on them and mark them at $300 and leave them on the shelf forever. So if somebody is interested from Germany or knows somebody who might be interested, they are in German. So they would, probably not sell very fast here anyway, even though at our store we mark everything way, way, way down. We're not trying to charge the going rate for used books. But if anybody speaks German or knows somebody who does, who might be interested in this lot of Nietzsche books, there's also some Kant, some other stuff like that. So let me know. Email me, jeranism@yahoo. So back to what we were talking about. Let's continue on with the movie. And so like I was saying, I put out that video, Research Flat Earth. When we're down there, Missa always puts them at all the gas stations. Anytime we go into a grocery store or anything like that, she'll just leave them on the counter. They're very bright. They catch people's eyes. And I think that they are interesting little call-outs. So it's something that if you want to print those, they print nice and bright. You could even print them in black and white, though. It's something if you have a hard time speaking to people about Flat Earth, but it's important to you to get out what many of us would call the truth. Well, I think this is the best way to do it because you're not going to ever tell anybody that the Earth is flat and they believe you. I'll be the first one to tell you that. It's just not something that can be realized by people. Well, I'm sorry, it's something that has to be realized by people. So I think the most powerful 3 words that there are is Research Flat Earth. Because it's giving permission to people to do something they never thought they had any reason or right or reason to do. So most of us didn't. All of us didn't. But once people, and I haven't had a whole lot of people that come back from a research and say, no, I still think the Earth is a ball. If they do, then those people are very clear to me. Chris over there at Hoaxbusters Call. There's some other people who, simply don't want it to be true, and that is the only obstacle. If you have a vested interest in the ball model, if you have cursed God for years, if you have been a staunch atheist and called Christians idiots, if those kind of people definitely do not want the flat Earth to be true. So if you have that opinion going into it, well then, yes. And I get people all the time who tell me you don't want the ball Earth to be true, and that's the most ridiculous story I've ever heard. That I want what I was taught my entire life to be true. It just so happens that I simply see that it cannot be. That there's too many holes, and when you look at the history of how we came to these conclusions, they don't add up logically. They're not actual real events. They didn't figure out these distances and all these things like we're told. Eratosthenes did not measure the circumference of the Earth in 325 BC. These kind of things did not happen the way we're told, and, well, we've been lied to. And at that point, well, why are you going to trust liars? It's hard to take some things they say and believe it, and some things they don't. It's better just to question everything, and that's what I think we need to do. And there's no problem with doing that. If somebody has caused you to question everything, then you question everything until they've earned back your trust. So if, as I was going through my research, I was finding that NASA, time and time again, was bang on with what they say and what we see and how actual reality is, then I would say, you know what, I've probably given these guys a bad rap, so it's time to start, giving them some more rope and believing in them. But that's not at all what I find. It's not at all what I find, and we're going to get into that a little bit later, talking about Redstone Arsenal and Marshall Center. So we'll talk about that, but let's continue on. We're just going to get a little bit more out of this video, at least so we can get through the launches. I want you guys to see the so-called launches of these two satellites and talk a little bit about how can they be fooled. How would it be possible that they can
Some
fool
sort of innate drive, I think, that we have as a species.
One of the key things that made this mission possible was gravity assist. That is, when you fly by Jupiter, you turn the corner and you take a little bit of Jupiter's orbital speed with you, like a slingshot. So you better make sure Saturn's in the right place.
The positions of the outer planets presented an opportunity. A rare alignment meant the time needed to cross the solar system could be slashed.
Again, somebody can explain it to me, but I don't understand. The time to cross the solar system can be slashed. The thing went to the left to get to Jupiter, then went to the right to get to Saturn, then went right, and then went out there. Why not just go out towards the other way? I don't understand. But it just doesn't make any logical sense.
Can we go Jupiter, boom, Saturn, boom, Uranus, boom, Neptune, boom.
The planets had to be lined up in just the right way to allow one spacecraft to do that.
And that lining up only occurs rarely.
That only happens once every 100, more than 100 years.
175 years, something like that.
Once every 176 years.
Glad they know the number.
Previous time it happened, exploration was wooden sailing ships.
It was named the Outer Planets Grand Tour, and the cost of the mission was estimated to be in excess of $1 billion. The NASA administrator went to the president, and he said the last time the planets were lined up like that, President Jefferson was sitting at your desk, and he blew it. So Mr. Nixon laughed. He said, "Oh, all right, just do 2. So, only 2 planets.
Jupiter and Saturn were officially a go. It would be a less grand, but still ambitious tour. Yet the Voyager team wasn't ready to give up on going farther. As they assembled the spacecraft in a giant hangar, some of them kept a secret goal alive.
We knew right from the get-go that we were going to try as hard as we could to extend the mission to go to Uranus and Neptune.
We designed that in from the beginning. We knew that we were endowing Voyager with the option, if the chance was there, to use it.
We didn't want to build anything into the design that would have prevented us from going further. So it was a mission within a mission, yeah.
A group of scientists and visionaries realized that these spacecraft would leave the solar system. They figured, don't let this opportunity pass. You're going to throw a bottle into the ocean, put a message in it.
So the next part of the video, they talk about the golden record. I'm not sure how much you know about that. Something that Carl Sagan had a lot to do with, also his wife, his child. So you can watch that. We're going to get to the launches here first, after they talked about the golden record. And we are there. Okay, and let's see here. Oh, and Rob said that the damn chair shot is getting old. I disagree. Patently disagree with that. Oh, the flag's not moving though. We do have to fix that. I disagree. I think that watching the astronaut get his head knocked off every time is hilarious. But that's, that's me. Let's see here. I want to make sure that I get the flag to work for you. So we're going to fast forward this, and let's see here. And back on this. Oopsie. Now I screwed it up. That was good. All right, now we're good. And there we go. All right, we're back. There. Okay, let's go on from here.
But you're up against Chuck Berry's Johnny Be Good, which Bob Dylan himself would, and it's awfully good single.
In the summer of 1977, final preparations for 2 launches began in Florida.
When it was launched, it was, of course, all folded up. It was like origami.
Here was this almost unexpected encapsulation. I mean, we knew that we were going to be encapsulated, but the emotional effect on that was kind of surprising. I noticed that in just looking around me. I realized that this was the last time any of us were going to see this spacecraft with eyes. And that's a fairly moving experience.
Journalists converged on Cape Canaveral to cover a once-in-a-lifetime mission.
When the reporters came to the launch, they all wanted to know more about the record. Most of the press release drawings show the other side of the spacecraft, so you can't see the record. There was always a lot of ambiguity at NASA about this. There's no question that the Voyager record is useless from a scientific standpoint, and the officials reluctantly arranged a press conference. The press conference was a joke, really. It was held in a hotel room separated by one of those accordion folding barriers from what was literally, as memory serves me, a Polish wedding reception. We did the whole press conference with the oom-pah sound of a wedding reception next door. But I think the public seemed to get it.
Environmental control ready. Roger.
We actually launched Voyager 2 first. And this gave the media, drove them nuts. We launched Voyager 1 later, but it was launched on a faster trajectory. So it overtook Voyager 2 in December of 1977. From that point on, Voyager 1 always got to the planet before Voyager 2, and the press was happy. They understood it.
We have just had a report from John Cassani, the Voyager project manager, that will be able to count down at 10:25.
After 5 years of planning, the assembly of the spacecraft's 65,000 parts, and untold mathematical calculations, it all came down to this.
Untold mathematical calculations.
5, 4, 3, 2, 1, We have ignition, and we have liftoff.
You see those solids ignite, and you're really not prepared for what's about to occur. The sound waves then catch up, and then this forceful shaking. The body is actually moved in resonance with this energy.
That's why the Indiana Jones ride at Disneyland is exciting. Is because they've learned if they grab you, if they move you, then you are taken in by the activity. Just like Universal Studios. Just like all these theme parks that move you so that you feel like you're a part of something. They do the same thing with these launches. And somebody should check underground or somewhere near for people shaking a bunch of fiberglass sheets.
Shaking you, right?
We were sitting in bleachers, and they keep you pretty far from the launch vehicle because they can explode, and basically it's a big bomb.
So there's a little bit of holding your breath and wanting to make sure you see it get that first little motion off the pad starting into space.
You're all thinking this thought, there it goes. And it's going to be out there to represent us for the next 5 billion years. There were outbursts of joy. We were on our way.
And then we launched it, and then other things went crazy. The spacecraft began to do things that we had no expectation that it would have done.
Voyager was not in control of itself. It's just riding this big rocket. And that was shaking it in such a way that it thought it was failing. And so it started switching off various boxes, changing to the backup this, to the backup that, trying to figure out why all this stuff was happening.
As the launch vehicle leaves the launch pad, it has to roll through a certain angle to get to the right direction for departure. And the rate that it rolls at is a much higher rate than the spacecraft would ever normally experience flying.
Okay. That is the most ridiculous thing I've ever heard. Let's hear that again just to make sure we're not hearing things. That you know you're going to launch the spacecraft in a rocket. That's part of the plan. So if you have to plan for certain trajectories or certain angles, I'm pretty sure you would include the launch in the specs.
The spacecraft began to do things that we had no expectation that it would have done.
Voyager was not in control of itself. It's just riding this big rocket. And that was shaking it in such a way that it thought it was failing. And so it started switching off various boxes, changing to the backup this, to the backup that, trying to figure out why all this stuff was happening.
Wouldn't you just turn it off? Wouldn't you turn it off till it got to space? Why would the Voyager craft be doing anything inside of the rocket when the rocket is launching to space? The fact that people buy this stuff is ridiculous. It is so much a story meant to fool people. It's just one of those stories that people tell, like your grandpa sitting around the fire, but you're not allowed to question him because if you question him, you'll get hit in the face because he's just telling a story. You should recognize when somebody's telling you a story that doesn't need to be questioned point by point because it's just a story. But these guys' story is supposed to be scientific and true. But we're supposed to act the same way. We're supposed to respect them like they're our grandparents. We don't question them. When they say the spacecraft was thinking something crazy was going on because it was in a rocket and it didn't expect to be in a rocket.
As the launch vehicle leaves the launch pad, it has to roll through a certain angle to get to the right direction.
Right, a known angle. It definitely has to go
for
to
departure.
Right.
And the rate that it rolls at is a much higher rate than the spacecraft would ever normally experience flying. And so the gyro hits the stops.
Oh boy.
Us poor people on Earth were like, what is it doing?
For a couple of days, it was a real nail-biter, and people were asking us.
For a couple of days, it was a real nail-biter, meaning this thing went up in a rocket and got dunked in the ocean. And for a couple of days, it takes the man behind the curtain to get everything programmed right so it can return the data that these scientists wait around at their computers waiting to hear tones.
If you lost the spacecraft, then we would say, we don't know for sure, because we didn't know for sure.
And the headline read, Mutiny in Space. The Voyager spacecraft had decided it just didn't want to follow the instructions that its human controllers were giving it.
Right, that happens all the time. Spacecrafts, machines, decide they don't want to follow the instructions that were given to them. The things that were programmed. Now, you want to do that? I'm going to do my own thing. I am Voyager spacecraft. I have been endowed with rights by my creator to make my own decisions. I have free will. Talk to you guys in a couple days when I get my shit together.
And it was going to do what it wanted to do.
It was so early in the mission, it's like, oh man, is this mission going to be plagued with problems? Is there some fundamental flaw in the design? Or?
Considering you lost it? Probably.
That was a cliffhanger. That was the end of the mission. I could have been the end of the mission.
Fortunately, the person who had written that code was able to say, this is okay, it's doing this, it tried that, it's doing this, it tried that, and calm everyone else down. The limits were set simply too tight. It needed to be able to wiggle more and vibrate more.
Finally stabilized, Voyager 2 was bound for Jupiter. The launch of Voyager 1 was coming up fast, so the team scrambled to fine-tune the spacecraft software to head off another mutiny. With the launch window closing soon, Voyager 1 finally took off. But rocket science is famously complicated.
Centaur 6 is lifted off at 8:56 from here at the Cape Canaveral Airport Station.
We're thinking everything's okay, and then we begin to hear that something wasn't right.
I looked over at him and he looked like he was a little worried, and I says, "What's the matter, Charlie?" And he says, "I don't know, I don't think we're gonna make it, There was a leak in the propellant line, and we were losing propellant overboard. So while it was burning, propellant was escaping from the launch vehicle. And second stage never got to deliver this full thrust because it ran out of fuel.
And so the upper stage, which was a Centaur, liquid hydrogen and oxygen stage, had to make up for that.
And the Centaur is the stage that's doing the guidance. So the Centaur knows that it's not reaching the required velocity. And when it separates from the second stage, it knows it has to burn longer to add more velocity.
The Centaur had to use 1,200 pounds of extra propellant. Now we're all thinking, is it going to have enough left in the tanks? Or is it going to run out of fuel? Fortunately, it had 3.5 seconds of thrusting left before it had run to fuel depletion. 3.5 seconds. So Voyager 1 just barely made it.
It wouldn't have gotten enough velocity to get to Jupiter, So instead of getting to Jupiter, we'd have gotten almost to Jupiter, and then we'd come back toward the sun, which would not have been good.
I watch the distant lights go down the runway, disappear into the evening sky. Oh, I'm with you on your journey.
It's worth realizing that a human life ago, less than 100 years ago, 87 years ago, the universe consisted of one galaxy, our Milky Way galaxy, in a static, eternal universe with eternal empty space. We didn't know about the other 100 billion galaxies a single human lifetime ago.
In January 1979, Voyager 1 was coming up on its first planetary encounter.
So just think about the cockiness that you have to call people who are religious to say that those people are cocky because they think that their lives matter, they think that a God created them or cares about them, or they call that cocky. What they don't see as cocky is that they believe the Earth has been here for 4.54 billion years, and that in that one lifetime, in that one lifespan of 100 years, 100 of 4.54 billion, that they exist. Lawrence Krauss exists during the 100-year period of time where they have discovered how long the Earth has been here, how long the universe has been here, what happened at the start of the universe, how everything is held together, that they know it all. Not 100 years ago, right now, when Lawrence Krauss is alive. Thank God for Lawrence Krauss. Thank God for Richard Dawkins. What would we do without these men who have told us how the universe works? because it's very important to know exactly how far the stars are. We have to know exactly that they're, between 30 and 70 light years, or, more or less. It is absolutely cocky and just ridiculous that these guys don't see what they're doing. So that was, I'm not going to play any more of that video. Again, you can go to pbs.com, and I think it's pbs.com/the farthest. I think I said furthest earlier, but I used the wrong form of that. So it's farthest when talking about distance. So yeah, it's called The Farthest Voyager in Space. It is a full-length hour and 45-minute film with the all-time high of CGI footage and not a lick of reality. Not a lick of real pictures. Let me show you what they do show. They do have what they consider real pictures. Here's one of them. Let's see this.
But to see it in action.
Another feature of Jupiter's dynamic environment posed a great danger to Voyager. Powerful radiation might destroy the spacecraft's electronics.
Every day you're wondering, did we build a spacecraft well enough? Did we anticipate all the possible things that could go wrong? You're approaching this monster magnetic field, this monster radiation environment on purpose, because you need to get close, because you want to see all the little moons and the clouds and the storms, and you want to slingshot onto Saturn, but you just don't know if you're going to survive. Thing gets fried, you lose the mission. Still out there physically intact.
So sad, so sad. So let's move on here. Want to talk about a couple things. I did see somebody in the chat mention something that I did want to discuss. We're going to go over this first. I saw a video by Wolfie 6020 today where he was talking about the ISS. And he was saying that flat earthers should go out and try and film the ISS. And I think what the one thing people, again, I've mentioned it many times, but they don't seem to get it, that because something crosses in the sky when somebody says it does, even if it's shaped like the thing they say it is, does not mean that that is true. It does not mean that 65-year-old Peggy, the genius scientist, has been up there for so many days and just came down the other day. It doesn't mean that that actually happened. Okay, we can say, oh, well, it looks like that's what it is. Great. But there's enough wrong with their story that should call it all into question. Again, I keep going back to the idea of there being no camera on the moon, that they don't have a 24/7 video feed of the Earth from space. That is the biggest kick in the balls there's ever been in the world. And the fact that all the space boys, all the fanboys don't see a problem with that is evidence to me that they are blind to the whole entire thing that we're saying. If you can't see a problem with that, then you're right. I don't want to tell you about Flat Earth. Don't watch my videos. Don't come to my channel. Don't. Why would you? That you're just going to hear me talking about something that you aren't capable of even conceiving, because you're locked up in the in your worship of men. That there are great men who can do great things, and so if they say they're putting up crafts in orbit, then damn well they are. Even if Arthur C. Clarke had to come up with it, science fiction writer. It's what we do, okay? And when you tell me that the ISS is faked because they're putting multiple high-altitude planes or balloons into play, well, that's impossible. That's too much work. But sending a Voyager spacecraft with a golden record to orbit Jupiter and then slingshot its way to Saturn, that's possible. The fact that we talk to a spacecraft 13 billion miles away, that's possible. But that they fake the ISS footage? Are you kidding me? That's impossible. That's what these guys' mindset is. It makes no sense to me or to anybody who's thinking logically. These things are just told to you, and you have a choice. You can believe them, or you can call them to question. And again, there is no problem with calling things to question. There's no problem with questioning authority. This is something they missed teaching us in school. I wonder why. I wonder why we weren't taught as children to question what we were taught in school. Why would you not teach children to question what they're taught in school? seems to me like the answer's pretty damn obvious. When you get to a certain age and you realize, well, that's a lie, well, that's a lie, and that's a lie, and you watch your country continue to have Columbus Day. We see this every year. Columbus Day, Columbus Day. Here it comes. Another day for Columbus. We don't even have, the presidents have President's Day. There's a bunch of them that have to celebrate on one day. But we get Columbus Day. The day Columbus, who never stepped foot in America, came over and discovered the New World. And that's a joke. All you have to do is read the books and by his brother and the people with him to see that he was a tyrant. He killed people, he jailed people, he murdered babies, and he was lost. Till his death, he thought he had hit India. And then he went even further and thought he hit Japan or China or something. But it's just a joke. So what we're looking at now is, let me bring this up so I can see. These are the passes. So what happened is Wolfie 6020 was telling us that we should go out and film the occulting of the sun or the moon. Now, I've never thought about doing that because the sites I go to don't give me any option to track that. But he gave a site. We're going to go there now. It's called International Space Station Transit Finder. So the first thing I did was enter my latitude and longitude, and then I hit the elevation, and it came back and it put me at, or it said that I didn't have one upcoming in the next 30 days. But then it asks down here, you'll see here it says, would you like to travel any amount of distance? And I put in, at the time, I think, 80 kilometers, or it's already there, yeah. And did it again, and it actually brought up a path. So let me see if I can get this in here. Let's see here. I don't remember now. Do I have that open? Hold on one second. I got to find my longitude, latitude. Okie dokie. Where is it? I don't know. 1 second here. We're going to pop this off for a second. 1 second. And we'll do auto detect. And then it'll put me on my map here. Auto detect. That didn't work either. Select from map. Okay. Out in the water by Africa. Great. Okay, well I can bring this back up now. So I'll show you what's going on here. We're going to put this one back up. Okay, and back here. So we are getting down over here. Come on. Go over here. Man, this thing won't let me use my scroll bar. Alright. So what it did is I'm going to actually put myself where it's going to have me going right here. And we'll get a little bit closer. Alright, so right about here where this city of Gonzales is. Chular, Gonzales should be right in here. Yeah, here. And this road right here, River Road, we're going to drop this thing here. We're going to save. Okay, that's got that. We're going to calculate that. So when I ran this through, and you know, it didn't go this order. I actually did my home first, and then it told me to go to this place. Should come back here. You'll notice something interesting. Tomorrow, as in 12 hours from now, at 4:37 a.m., there is a lunar transit going directly across the moon. So when I hit show on map, we're going to scroll down here and see. So this purple band is the stretch of land that a person would see the ISS cross the moon. So this happens to be less than, I live, oops, this thing's in the way. Can I move this? Well, I live behind this white thing. So it's not more than a 20-minute drive for me. And that's my plan for tomorrow morning at 4 something in the morning. I will try to be live. I'll have my camera on, and I'll have my phone on me. So I'm going to actually be right here at this location. I think it's awesome. It's going to be very dark, or it might be getting light, but we're going to be right here looking in this general direction. The moon will be setting, and we will be seeing the ISS supposedly transit the moon. So I'm excited about that. I've never seen the ISS. I've seen the light, but I've certainly never been able to get any kind of a figure. I've seen it done by others, so I don't doubt that there is something in the sky that's the same shape. Again, it doesn't mean that they're people in that craft, nor does it mean that the people in that craft, if there are as high as they say. A lot of things can be the case. So I'm going to take that step, and that will help me get closer to the truth as far as that goes. This looks like a great little spot. I'm going to camp out here somewhere and set up the camera and check it out. So yeah, Miss and I will be there, and if you saw where the location is and you live anywhere close to here, 4:45 in the morning, you should see my big Ford truck out here getting ready to look off in this direction. And the only thing I'm kind of worried about is I think that the altitude said, if I remember, 15 degrees. It's going to be close. I mean, this is about, I'd say this is 10. I'd say 15 is going to be, no higher than this. So it's going to be close, but it's worth a try. I did try and change my location. How do I get out of here? Oh, yeah, this one. Let me see something here. Make sure you are watching me, right? Okay, good. I did try and change, because you can basically run yourself along this center line of... Why would you not let me use the scroll bar? You can run yourself along this purple line, so I was trying to see if there was a better location. As I get closer to these mountains, obviously the mountains are going to creep up in my perspective view. That's not going to be good. If I could get over here, the only problem is Highway 1 had that landslide after the fires, and I believe that this stretch is still closed. But Highway 1 would have been a great place to go. I wonder if it'll let me get down there and show you what Highway 1 looks like. If you've never been on Highway 1, I'm sure everybody who's lived in California has. Amazing little drive through Carmel and down the coast. Some of the most beautiful scenery. Oh, good, it's going to let us go here. So we're going to drop onto Highway 1 right here, and you'll see it is just beautiful. So this person would actually be seeing the moon set here. Now, I think that this road is closed right now because of the landslide. It was huge. It's like a quarter-mile or more landslide that happened fairly recently because this whole hill went on fire. This whole hill was the big fire. So anyway, I think I'm going to be at that spot. That's the plan for now. And if I have to go somewhere else in the future to check it out. But anybody who's out here, as long as you're within this purple, now you won't get the center view. That's why I'm kind of excited about being right there where I was, because that is the centering view. And it says, if I can bring that transit up again, where am I at? It tells you how long, right here. So I'm going to drop down here. Okay, here we go. So right here it says transit duration 3.28 seconds. That's a pretty long time. 1 1,000, 2 1,000, 3 1,000. So, when we saw Smarter Every Day, it certainly flew by faster than that, so I'm not sure if this is correct. It just says transit duration 3.28 at an altitude of less than 14 degrees. ISS angular size. So, just so Wolfie knows, I certainly am not avoiding doing something that I didn't even know they had a calculator for. So, certainly very cool. Again, if you put in my location, it didn't come up. It said there was nothing. Then it asked me if I would travel, and that's because I live in Salinas here. And if we are here, we will not see the ISS transit the moon. It would be very close, but it would not do it, I guess. And I'll have to figure that out a little bit with the math and make sure that's all correct. Can't really conceptualize that in my head. If people remember a while back, Miss and I had a unique viewing experience that still holds true regardless of this. Well, it holds true because we saw it, but number two, it doesn't really, mean that we saw anything out of the ordinary. Because when we were trying to do the 8-mile test, basically she was right here at this dock, and I was over here past Sand City. I was almost by this green. So we were 8 miles across here, and after we weren't seeing anything of each other, it was tons of boats. She shouldn't have been here. There was boats all out in front of her. Just a bad spot. Tide was out. So we were just sitting on the, apart from each other, talking on the phone, and we were tripping out at the planes, because if a plane was coming towards Monterey Airport, this way, Missa would see it up and to her left, and if I was standing here, it would be way over on my left. And same thing with her. If she saw a plane out here, just the weirdness of where we were, and we were basing everything off the stars above. So, she may see a plane 60 degrees differently than I would see it. So then, because we had just been recently looking into the ISS and watching it on its passes, she happened to look up and say, "Oh, I see the ISS." I said, "Oh, where?" And she said, "Oh, I see it. It's going towards the Big Dipper." So I looked up and I said, "Oh, I see it. And then I said, is it going towards it right now? And she said, yep, it just passed the second star. And as she said that, it did the exact same thing for me. And we tripped out because we said, wait, hold on a second. Everything else, every plane was displaced by a huge amount. But the ISS, and I said, it went directly over the second star. And she said, absolutely, went right over it. And I said, I just saw the same exact thing. So we had a question about that. That kind of told us that possibly the ISS was at the same height as the stars, or it could be like the globe model says, that the stars are an infinite distance away and the ISS is much higher. But that would be the case because what we're saying is here with 8 miles distance between us, we both saw the same transit position. Whereas over here, you're seeing that same kind of thing, right? This is not 8 miles. This is much larger than 8 miles. I wish there was a measuring stick on here and there's not. Oh, wait. 1 kilometer. Maybe this is about 8 miles then. That doesn't seem like it if I'm over here and that's 8 miles. Let's see, from here to here. Yeah, no, this is way bigger. Should be double that at least. So, it still seems weird though because basically if I'm standing here at this red marker, I'd equate where Missa was about this far away. We shouldn't see the same exact location, meaning if the ISS flies over the exact center. My question would be, so we can move it. Watch, I'll move this to over here, and we should see the ISS move accordingly. Watch. So now it should be to the left side, if I understand correctly. Oh, no, that's interesting. So that shows it missing it. Okay, well now we know that purple thing's a bunch of bullshit. Because didn't I click in it? Let me go back down here and see what I did wrong. I didn't think I clicked that far out of it. Alright, let's go click here. So this should not be... Okay, this is better. See now how it's showing this pass to this side? And if we go a little bit more this way, it's going to be a little bit more, and then we can move back this way, and we're going to see the occulting of the positioning change accordingly. So now, another question would be if we start moving this way. So we just figured out moving in this direction, which would be, can't see the compass to tell you exactly. But if we start moving this way, what should happen? You would think that it means that the ISS is going to drop or rise. But I noticed that it does that on a very small scale. Because you can just keep popping out in this location. Another interesting thing about this, and again, I'm just voicing things I'm thinking about, but this altitude doesn't change. So, kind of confused on that one. I've got to think about it. If anybody's got any ideas, they can email me. But there's something in here. There's something definitely here. Because if you're moving inland more and more and more, and the ISS should be getting further away from you, you would think that because of the way the sky works, that it should be dropping in the horizon or rising on the horizon. But it doesn't seem to do so because the moon would be in the same spot, meaning the ISS is going to cross the moon for all these observers. I wonder how far you can go until that runs out. And again, I'm not even saying there's anything wrong with this. I'm just thinking out loud. So you can go all the way over here. Is it still the same? That's interesting. Man, that's still at 12.3 altitude. Well, I guess that is dropping technically. 12.1, but they're still showing it. Yeah, I'll have to look into this. It certainly is interesting. The transit duration gets longer. Now it's at 3.62. So very interesting. But that is tomorrow, so you can check that out. Hopefully on my channel I'll be live at least showing you what I see through my camera phone, showing you what the camera is set up to take. And I'd be excited if I saw the shape of the ISS. I mean, it would tell me at least that whatever they have up there is shaped like the ISS, and that's what my goal is to get closer to the truth. It certainly isn't anything other than that. So if the ISS or the craft up there is shaped like the ISS, then I move forward with that understanding. So thank you, Wolfie, for doing that video and for pointing out that site that I did not know existed. If you can't see it, I don't think you can see my URL bar. It's called transit-finder.com. So check that out, and you can just put in again when you get to, how do I get back here? Close map. Yeah, you basically put in your longitude, latitude, and then from there you can 257 meters. Who is that? Oh, I was way over there. Sorry. And then it will tell you upcoming. So I'll just put in a fake one here. We'll put 36.02. 121.9. And we'll say the height is 30. And for the dates, we'll go today through, and you only can do a month, I believe is the most it'll let you do, so we'll go through 10/4. And we'll say we only want to travel 20. And then we'll calculate from there, and we'll just see how that comes up. Okay, so you'll see here, with those locations, we found one upcoming lunar transit and one solar transit. I think this site's kind of dumb for doing this, because why would you want to know if it's just coming close? It's not going to really do you any good, unless the time is the time where you would supposedly see the ISS because of Earth shine, or I'm sorry, because of sun reflection. And during the day, I don't think you'd ever see it, even if it got close to the sun. I don't know. Maybe that's why it's interesting for people. They should check it out. I don't have a solar filter yet, but if I did get one, then I would be interested in doing a solar observation, which I have not done either. But it should be interesting. I'm hoping. Here's the other crazy thing. I'm forgetting to tell you. I mean, talk about luck, luck of the Irish here. By the way, I'm not Irish, but maybe one of them threw some luck on my house. I don't know. But the moon phase is full. So that's something I didn't even mention. That what are the chances that on the 5th, the day that this occulting is happening, the moon will be 99% full. The full moon's on the 6th, but that's pretty cool. If there was any 2 days that I would want it to be, it would be those two. So that's pretty exciting. So a full moon and a transit of the ISS, in which with the P900 should be able to super zoom in and at least see a figure, because I've never been sure about the figures that anybody gets, because sometimes they just look off. It does not look like, let's check out some. We'll see ISS images from ground, and let's check out some of these. Those are ridiculous, but let's see images. So, I mean, this right here, does this look like the ISS to you? Doesn't to me. This looks like a high altitude plane. I could even show you the plane that it is. This is just, it does not look like the ISS in any way. So on the occulting, let me see if we can find, or the transit, let me find a ISS transit image of the moon. ISS transit, let me see what I should see of moon. Okay, so I mean, like, I would be amazed if I saw this. If I saw this image, I venture to say that I don't think this is what you see. Again, I could be wrong. That's why I'm doing it, and that's why I want to test it before I just jump and say, no, it's absolutely fake. This does not look like you would see it. But I would be anxious to see, because even the Smarter Everyday one that went across the sun, they saw something more akin to this. And it's certainly, it's just interesting that it looks like that. Let's see here in this one. That does not look like the ISS to me. So I'm really excited about what I might see. So anyway, that's very cool. Thank you again to Wolfie for bringing that site to my attention. I wouldn't doubt that something like that might be seen. Okay, I think that wouldn't surprise me. But kind of a clear-cut picture like that other one we just, where was that other one? What a joke that one was. But who knows? Maybe I'll see that. I don't think that that's what you would see. This one here, that's pretty detailed. I don't think you'd be able to. I mean, you can actually like see the solar pad. It just doesn't look like something you'd see. See this one? Yeah, that I wouldn't doubt this one. I wouldn't doubt that this is something you could see, because to me that's easy to put up in the sky. And again, even if we see the ISS, and it's shaped exactly like the ISS, it doesn't mean that there's people in the craft, nor does it mean it's as high as they say, nor does it mean it's going the speed that they say. So there's a lot still that goes into it, but I think we can build a better path towards so-called truth by eliminating possibilities. And so to say that, everybody just fakes their images, which people will say about me too. Luckily, I don't give a damn. People can say whatever they want. That's on them. But for me, doing an observation and actually believing in something because you've done it yourself, there's nothing better than that. What is that? that is, yeah, see, I don't believe that at all. This one here, I venture to stay straight out. This is a fake. That one does not. I mean, that's, yeah, I don't agree with that one. I mean, this doesn't even, this is when there's one solar panel. Is this what we're supposed to believe or something? So, I don't know. So anyway, I won't say much more on that. I want to see it. Yeah, I don't know. And again, should we be surprised that they can put things up in the air? Well, no. They've been doing that for 100 years. So, okay, this one here is a running joke. Oh, yeah, that's real. Who's this one? Julian Weasel. Yep. Julian Weasel with a nice picture here. I love it. Right here it says fake picture of Saturn and the space station. Good. I wasn't the only one who caught on to that one pretty quickly. Yep, that looks pretty real. Yep. Just paste in planets over here. But didn't you guys... Oh, that is a joke. Somebody's not claiming this is real. To get an idea of the speed of the eyes, the entire 8-second clip can be downloaded from this webpage. Let's go check this out. I want to see what this person's talking about. Thank you very much. I don't believe that. I mean, I haven't even seen somebody get a good image of it. In fact, the guy that went with Destin has a website, and I can't remember it now, but he has all these pictures, astronomy pictures, big old, all kinds of stuff. And he has one picture of the ISS going over the moon. And so I emailed him and did ask, hey, do you have any other pictures of the ISS? He says, no, I can never get it. It's always real blurry. I've never seen it up in the regular sky. So then he was talking about getting some tracking device or something for it. But, hello, are you going to get there or what? Maybe we're not going to get to see the... Oh, come on. Whatever video they're talking about here. All right, doesn't look like it. Let us continue. Oh. Great, this whole time I've not been on the right channel. You gotta be kidding me. Or have I? No, I have been. Okay. So I wanted to show you a couple things here, and you know what? I need to open Google Earth 1 second. And we'll cover that, and hopefully, yeah, that should be good. I'll be done in a few. And so, yeah, be paying attention to the channel. I have the video I'm finishing up now is the one about the test that I want to be running probably by the end of this month. And I can just kind of give you a quick overview of it by just showing you. Oops, you can't see this. 1 second. Let me add this. Google Earth. Let me bring this up for you. And we need to, oops, sorry. You have to deal with that for a second. We're going to another video, and let me know in the comments if you want this done, or is it just a waste of my time? Do people want to know how to run OBS? If they do, for their own live streams, I'll do a quick video where I'll just screen cap everything that I'm doing so they can see how it's run and how I'm adding different window options and how to square them up, and you have to do a transform. It's called edit transform, where you basically change the size of the window and how you move from each to the other. So if people are interested in that, let me know. I don't want to do it if nobody cares. But if there's people out there who want to use OBS and don't know how, I'm not saying I'm great at it, as you've probably seen, but I at least understand it now and should get better as time goes on, not just continue to get worse. So let me bring up, let's see here, Google Earth Pro. All right, and we're going to square this one in here. So yeah, I think you're watching me do this live. Usually I do it on the other side. Okay, there we go. So we are going to drop down here, take a look. Is that on the screen? It is. Okay. Hopefully lined up. All right, great. Where are we? So the test is going to be, and I probably won't show you the exact spot yet, but I'm going to show you very close. Let's see here, because there's a few of these ones that I can choose. There's one that I chose on purpose, and I'm lost where I'm at here. Los Banos, Newman, Gustine. Okay. So the Sacramento River, and let me show you another spot. If anybody's got any good test ideas for here, let me show you a spot that's pretty crazy. Here you got Stockton, and Sacramento is way up here. This is the Sacramento River that comes out of the bay here. And this is the craziest thing I've seen. Watch this thing. How incredible is this? This spot right here. And this is public access. You can take a jet ski, you can take a boat, you can do whatever you want in these causeways. This length right here, what distance do you think that is? from this right here, perfectly straight to right there, 10.8 miles, 10.08 miles. Is that unbelievable or what? Look at that. Straight shot, river shot, water shot, all the way down, 10 miles, completely flat, completely straight. People think it curves on a ball, and they would be sorely mistaken if we did a test there. That's a tough one. I don't think you can get a laser to correctly get your, if you're going to measure with a laser, I think we'd have to think of something else. I'm just looking up the curve calculator real quick on 10 miles. So if we're doing 10 miles, let's say the observer is 6 feet high. We'll calculate that. It's a 32 feet. So that's, that's the kind of thing where if you put two boats in that water and each boat is 20 feet high, or, that they should not be able to see any part of each other. Pretty crazy spot there. Let me get over there again. So yeah, pretty incredible. And there's not a lot. I don't think you can drop down there. But you can get in there. I don't know if there's a lot of access to the sides here, but there is access to, right there I can see. Hold on, let me get over here. So we can actually see kind of what it looks like. And again, these things are deceiving because you're looking at that probably thinking it's very small. It's huge. We're going to drop down to this road and see if we spin around. So you'll see this is the waterway here. But, we've heard tons of talk of the Bedford level experiment, and that being a straight set 6 miles down. This is 10 miles. 10 miles, straight as an arrow. So pretty crazy there. But my test involves being a little bit more small. So basically all these little channels you'll see that come out of the Sacramento River are all great little spots. And if we get down in here, you'll see there's a lot of these stretches. We'll measure this one off here. We're going to go from here to here. So that right there is 6.8 miles. Okay. So then we can even find, as we get down into the other areas, let go of that. You can find even smaller channels that also pop out and have these straight shots. Okay, there's this one here. So we can measure from here to here. And you'll see that one's 3.7 miles. So let's go down on that one and check it out. So if we were doing my test here, what we would be doing is we would be going down to this road. As you can see here, there's a road that runs all the way along this 3 mile stretch of river. All the way down, it's a straight shot road. To get to the other side, again, that's 3.7 miles. We would only be doing 3 miles. Let's pull it back till we're 3 miles. Okay. You would have to have access to both sides of this river if you were going to do the test the way that I'm planning on doing it. And basically what you would do is you'd set up, just as a quick rendition before the video comes out, you would set up 6 pylons as kind of our idea, which would be like a observing section. So here with a transit, with a theodolite and the laser set up here, leveled off, and down this corridor here every half mile. So I mean, it's pretty crazy because it looks short, but this right here to here, right there, that's a half mile. And let's see if we can drop down there and take a look. Yep, so let's go down here and take a look. And there you go. So here's us looking down at a half mile distance or so. Remember, this whole thing is about 3.7 miles. And straight shot back and forth. Not a heavily traveled road, this one. And you can just see that we can keep going all the way down. So what we would do is we would basically take 8-foot boards. They're about 4x2s, or 2x4s, whatever. And putting them in buckets. And these things would be sticking out 8 feet high, and it doesn't matter where they go. We're just going to be setting them kind of on the side of whatever road we're doing. And you would have these 8-foot posts sticking out of buckets all the way down every half mile. Let's pull it back out. So let's pretend this is where we were doing it. We would have the observer, half mile down, bucket with a post, half mile down, bucket, post, half mile till you got to the 3rd mile. Total of 6 posts. Then what we would do is we would take that laser and shoot it from the opening location here, about 2 or 3 feet high on a tripod, leveled. We're going to take the laser and shoot it until it hits the first post. When it hits the first post, we're going to drill through it with about an inch drill bit. And once we go through that piece of wood, then the laser should also go through the piece of wood and hit the next piece of wood. May not be directly on, that's why people will be there to move the bucket where it needs to go to be on line with the laser. Then we'll drill a hole in the second piece of wood. So on and so forth until we get to the final piece of wood at 3 miles down, at which time the laser is going to hit it. From my preliminary guesses, I think that the laser, it might be the only problem with the experiment, but I think people would all agree. The laser might be as big as like 3 feet at that distance. It's kind of hard to know. It's going to change too, depending on what time of day we do it. But the great thing about it is it is a good quality beam. And if it was 3 feet, well, we can measure. We'll have tape measures out there to come up with where the center of that dot is, and that would be the drill point. So people would be there to all agree that there's no funny business going on. Again, here's the thing about the experiment that is so cool, that if we are on a curved Earth, then we're going to know by the 3rd or 4th post. Because here's what needs to happen, and this should be for all you globe believers out there. If you don't realize from me explaining this right now to you why this experiment will prove to you that your Earth is flat, then you just don't get it. That even if we start at 2 feet and we shoot the laser down, the laser hits each of these posts, that just in 3 miles, we need to be drilling a hole 6 feet higher on that post than we drilled it at the first post. That's how much the Earth is supposed to curve. So do you really think when we spin around here, and the great thing about these axis areas is they're all kind of the same. If you look, there's all these crossways all the way through here. But there's another one, see? So if we're doing this one, people can actually go walk here if they wanted, and they would actually be able to take a long bird's eye view of this thing here by standing over here looking across. You would actually see the laser going across. But here's what you have to believe, that the laser is going to be shot across. It's going to hit the first post at 2 feet high off the ground. And by the time we get to the 3rd post, the laser beam will be hitting 6 feet higher. So that means, my height above where it started. So again, and that's why a few people have questioned me and say, wait, I heard you say something about if the experiment goes the way, well, if I get down here and I'm drilling a hole in this piece of wood 6 feet higher than I did at the beginning, then the Earth is curved. I would be an idiot to come up with any other reason why. And here's what we're basically doing. At the end of this, because a lot of things can happen with those buckets, right? The bucket could be lower here, higher here. We don't really know. But what we're ultimately going to do with the transit level is, the theodolite, is after everything is done, and basically when you have that piece of wood here, and we drill a hole through it, we're also going to mark on this side of it with like a white piece of white paint, mark on there where the hole was. The reason for that is because then we're going to bring the theodolite to the other side, and we're going to look across. And here's going to be the bucket with the post sticking up and the white paint going across it. And then what a theodolite can do, it can measure the distance from the level water to the white paint. So that's ultimately what the test is. Now, I say that we'll be able to know because the road is not higher or lower by 6 feet. The road might be 6 inches somewhere, but it's not going to make the drilling of the last post be 6 feet higher than the other one. But if we look across here, all you need to do is measure from the water to the paint. When you do that, this one here at mile number 3 needs to be 6 feet higher. So the post here would have to be way up here, 6 feet higher. It's basically like if you saw me standing over here, then somebody would have to stand on top of me, 6 feet higher than it was at the beginning. That's a huge amount, and that's not something that can be attributed to anything other than a curvature of the Earth, because the water is level. We've all agreed to that. So how, if we measure from the top of the water to where the post goes, or where the laser light goes, then I think it's the most definitive test there is. What I do think will happen, which will be interesting even if it does happen, is, and I talked to Jesse Kozlowski about this, and I think he agreed with me if I remember correctly. We also will have the transit theodolite over here. So if we've got a laser here shooting this way, and it's leveled, well then the theodolite should also, by design, or in theory, if shot down the same way, the theodolite should show all the holes. And I've got the portable sun. I don't know if anybody's ever seen it. It's a 6800 lumen light. If we go to the far 3 mile post and we pass that light back and forth on that hole, Well, when the theodolite is aimed in, looking through all the holes that were drilled, then it should see the light at the very end passing back and forth. What my personal belief is we will not see the light. And the reason for that will be monumental. What it means is that one thing is wrong. The laser light is wrong, or the theodolite is wrong. In my opinion, as I've said many times, theodolites are wrong. Theodolites are not taking into account, and again, this is why I wanted to get into the whole idea of the Bedford level. This is the problem behind the Bedford level experiment. And to explain it to people is tough. It's hard for them to grasp the idea of what's being said. And I don't know if now's the best time to do it, but I'll kind of give you an overview. That the whole Bedford level experiment issue was because, and I can't draw on here, huh? I don't think you can. If you picture the Bedford level, this is the Bedford level experiment, and you picture these people lined up here, and they angled, or they leveled the telescope. Okay, they leveled the telescope, and they're shooting these little posts that are sticking out of the water all the way down the Bedford level. Well, what happened was, when they measured them, they saw that the posts dropped below the, probably easier if I show you this real quick. It's only fair if you get to see it, and then it's also in the video, but the video is more for putting out exactly the parameters of it, and asking for anybody who's got an objection to please let me know what they feel is wrong with it, or what can be done better about it. And so that's going to be our goal of putting out that video. Let me see here. I'm going to pull, I know you can't see me yet. I'm going to get this just because it's easier to explain it, because I think it's hugely important, and it is really, whoa, what's going on here? That's interesting. Okay, and let me go this one. I got to add paint. And okay, and add window capture paint. Okay, so I just want to show you this so that you get this, because I think it's important. I think it's going to be one of the biggest revelations in a while once people gather this. Okay. So here's my drawing. We'll transition this over so you can see me. All right, so you should be on my drawing now. So here's something interesting that is kind of counterintuitive. It took Missa a little while to get it. Well, about a 15-minute conversation on Raw one night with a caller who also finally understood what I was saying. If we kind of picture this as your river, put some water in there. All right, so we've got this river. Make sure you can see what I'm doing. Yep. So we've got this river here, and let's say that there is a sidewalk or a little side piece over here. All right. And we are measuring with a laser light or a telescope. We're just using a telescope, let's say. And we put posts all the way down. Get a good color here. Let's go with this one. All right. So we're shooting from, say, this is our location here. That's where our telescope's going to be. Right there. And then every so often here, there's could be a telephone pole or whatever. Okay. From this perspective, we know that all these poles will be the same height. Okay, we know that. I can't draw them getting smaller because they don't get smaller from here. They just, I know if they're not the exact right height, oh well. Okay, so if this person was then to construct something tall enough to where he was going to then look down, give me this. And let's go with this color. Okay, so now most people would say, all right, we'd get up here and we'd get a telescope. Let's make the telescope green. And we'd level the telescope. Okay, we'd level the telescope and we'd look down here, and what would we see? Here's the strange thing. If we do that, and here's our telescope lens that we are looking through. Hello? Move this down. Okay, here's our telescope lens, and let's say here's our crosshairs in the telescope. Alrighty, and this way. Alright. So let's say that we are looking through this green telescope here. We're looking down at these posts. Well, what do you think would happen to the posts? Well, the posts would fall in the telescope. You would see, bless it. Oh boy. Sorry. I'll get this eventually. All right, there we go. Okay, so you would see the first post be at about there. That should be yellow. Okay, then the second post would be here. And the third post would be here. Now, again, these would be behind each other, so you can't draw that, so I'm just showing you like this. So when the Bedford level experiment happened, the Russell Alfred Wallace proclaimed victory by saying the posts went down, therefore the Earth is curved. And John Hampton and Rowbotham and those guys said, no, that it's supposed to go down. And if the telescope, when looking at these posts, does not veer from this line of drawing, see how I drew this line that matches all the way down to the horizon, then the Earth is flat. That what would need to be the proof of the Earth being curved is you would have the posts falling out of line with this line. So many people might get confused right now and say, wait a second, you're saying that we can't level the telescope? No, in fact, you would need to aim the telescope down. Now that could be, this is why it's kind of a weird conversation to have, because people are going to start saying, wait a second, then that means the Earth is not flat. Nope, it's wrong, because a telescope is not the same as your eyes. And the telescope does not understand how things diminish in size with distance. So if you think about it, here's the way I had to ultimately describe it to get Missa to understand. If we took a cloud, okay, let's say here's this huge cloud up here, 10,000 feet high, nice cloud, and we put a telescope on top of the cloud. We laid it on top of the cloud, and we looked through the telescope. Would the telescope see the horizon, or would it be seeing out into space? Well, the telescope would see out into space, because it can only see what's in its little viewfinder here. Its whole entire world consists of just that viewfinder. And so another way I've heard it described is, if you were to, say this is a railing, this orange thing is a railing. If you laid a telescope on this orange railing, well, the telescope, the railing would fall well below the line of the crosshairs of the telescope, because the telescope can only see this part. So what Rowbotham was saying is that because things get smaller with the distance, well, the telescope only exists in and of itself, meaning, let's get a circle here again. I said get a circle here again. Okay, so let's say this is the telescope lens, and we're looking through it. Oh boy, come on. Okay, so here's a telescope again. We'll get it a little lighter so you can see through it. Okay, that didn't really work. Okay, so let's say we're looking through this telescope lens, and we're looking at something that is getting smaller in the distance. Well, the telescope can't stay level with that, but we know that that's level. If things are like telephone poles are getting smaller off into the distance. So what Rowbotham said is you have to aim the telescope, because of the way reality works, it's not something that can really be argued, that if the telescope crosshairs are here, okay, you have to aim the crosshairs to hit the first post and the second post tops. Now, once you do that, if anything falls off of that line, the Earth is curved. So that's the difference, is that you have to aim the telescope, and it would be very slight. But if you aim the telescope and it hits the first two posts that are of equal height, then if the Earth is flat, all posts will conform to that line. And that's exactly what happened at Bedford Level, is that they took these stakes, and when they drew it out, the line stayed exactly perfectly even with the telescope that was leveled. So, with the telescope that was pointed at these first two. Then when they took the one that had this one going just off into space, well, each of these posts fell below that line, in which case they declared themselves the winners. And that's why basically John Hampton went crazy and threatened Alfred Russell's wife, because they were saying you cheated. But it was really two sides of the story. And in my mind, that's exactly what's going on with the theodolite. A theodolite is a tool that is measuring what it can see. It only can see what's in this circle. And so when things fall away in the distance, it's not measuring that. It's going to call that drop, which should make sense. I mean, if we looked out into the sky, into the distance, that the crosshairs of a telescope would be slightly above the horizon. Why? Because our eyes are above the horizon. Because, yes, we all have heard, the horizon always rises to your eyesight. That's not exactly true, because the horizon would technically rise to your feet. But again, that's imperceptible to us. We're not going to be able to determine the difference between your feet and your eyes. But a transit tool can, and they call that curvature. And it's not curvature. What you're looking at is a diminishing of the distant horizon, and it being met at your feet of the plane. And so they look at it and they say, well, it dropped this much off the crosshairs. Here's the crosshairs. We can measure this and say the Earth is curved this much. And that is ultimately the problem. So the great thing about going back to this test here is the reason I feel confident about this test is I'm going to walk away with one of two things, or three things basically. Either we're going to do this test and we're going to see that the laser light goes through and that the theodolite shows only wood, meaning the theodolite would look through the first 2 or 3 circles, but then it would see wood and not future circles. But from that, we can then walk away from that experiment. We would still do the rest of the experiment, of course. But what that's going to call into major question is, well, everyone says that theodolites measure the curvature of the Earth, but what we're actually catching here is that theodolites are forced to measure curvature, meaning they don't look directly straight. They don't look at how they're supposed to. So that would be a big thing for us. It would mean one thing is wrong. It would mean either theodolites don't show straight or laser light doesn't show straight. Now, if the laser, because I've heard people say, well, what if the laser conforms to the curvature of the Earth? Well, if it did, then it would show level, meaning the laser, we don't think it bends up. So if it hits 6 feet high, if the laser hits 6 feet high on this stick down here, then the Earth curved below it, which caused the stick to have to be drilled higher, right? So that argument doesn't even make sense, because what they're saying is if the Earth holds the light, meaning it's holding the light to itself somehow or some way, well, then it's going to show a level. It's going to bend the light down, not send the light up. So, that kind of defeats that whole argument. If somebody were to say, well, it bends it down, which is why it shows level, well, then what would their excuse be of why the theodolite also sees the same thing? So there's so much that can come out of this, and then when we come over here and measure from this way, it's going to be easily seen that, in my opinion, that if we got down here and said how far above the water line did we drill this hole, okay, we drilled it that's probably 8 feet above the water line, all right? And then we go over here and we say, well, how far did we drill this hole above the water line? If it's anywhere between 8 and 10 feet or 6 and 10 feet, the Earth is flat. And I don't think there's anybody that would argue with that. Now, if it's anywhere between, 2 feet to 5 feet, I would say that's a interesting story, because that seems to say that the Earth curves, but not nearly as much as we've been told. If it's 5 feet or above, I don't think I could walk away from that experiment without at least saying the Earth clearly has curvature. The Earth clearly must continue to curve, and my standing or my opinion of water not bending would be out the door. So that's why I think it's a good experiment. I don't think there's a chance of the curvature of the Earth. It just would not make any sense. It creates so many problems with the fact that water needs to flow from its highest to its lowest place. So basically what we would be proving in this experiment is that all of a sudden, we'll stand way back here, see if we can get the whole thing in sight. Yeah. So, and if anybody has a drone, wants to come out and fly this perspective, I want to do it about, maybe 4 o'clock in the afternoon, 5 o'clock, so that we get the best laser light right at dusk. Right towards the evening. So now if we got over here and we kind of looked at this whole thing, what we'd basically be saying is the post is hitting higher here, which would mean that the Earth is falling down this way, which would mean how in the hell is the water not flowing to the right? And that's how I know that the Earth is not a ball. I mean, this experiment to me is just one of those experiments, and for all the people out there who don't see that there could be an experiment, I've heard a lot of people say we can't prove it. There is ways to do it. They just need to be covered all their bases. And another thing, people I've heard saying, well, you keep saying this is going to be definitive. What if you do the experiment wrong? Well, the whole point of this is to get it as close to right as possible, and then do it again, and then do it again. And if we have to do it 3 times, it's not expensive. These people are going to take about $200 to give us access to this land. And besides that, we're buying some buckets. We're buying some 8-foot tall wood, and we have a laser, and we're renting a theodolite for, $34 for a day. And we need some white paint. You're really talking about a pretty inexpensive experiment. And if it doesn't go perfect, then we're going to figure out from there how to change it for the next time. There's no way that you can plan on being perfect. We're not funded by the U.S. government or anything like that. So I'm not expecting perfection, and nobody else should either, or else you are out of your mind. But I do expect results, meaning I'm going to be able to walk away and not say, well, I didn't learn anything today. And that's my goal, is that there's definitely a result that you will walk away from this experiment and have a different outlook on everything. You're going to either say, well, the Earth is probably curved, or you're going to say the Earth definitely does not curve, or you're going to say the theodolite does not measure straight. One of those things will be definitive. And then we can build from that. And that calls into question theodolites and every measurement they've ever taken that causes, they call Earth drop. When technically we'd be showing that it's not showing drop, its eyesight is only showing drop, which can be a result of the mirrors. It can be an absolute result. Just imagine if they had it fixed in, and I know, oh, you tell me all theodolite makers are in on the hoax? Nope. It's just something that's fixed into data. It's like a little tiny change of a 0.1% angle change in the mirror inside the theodolite would cause it to always see that drop. So these are the kind of things we're going to explore and find out. So I think it's a good test. At the same time, the one other test that we want to do on that day, because we're going to be there and it's going to be equally easy to do. Let me transition this over so I'll just show you one other test. What time is it? I still got a little bit of time. Are you looking at the... Yeah, you're looking at this. So the one other test we want to do, back all this out. All right, is once we have the stations set up, which will have the posts in them and all that fun stuff, is somebody called into Raw, I can't think of his name right now, but I thought it was an excellent test, is let's say this is our bucket with our stick, and this is our bucket with our stick. And these are, I think what we're going to do for these double laser experiment, we're going to do 2 miles instead. It's just going to be easier to manage, and based on my calculations, my beam divergence should be like, I think at 2 miles it was like 1.5 feet at the most. Again, you can't know, you have to basically use it with the most. It's going to be less than, just like I said that it would be a diameter of 3 feet on the third mile. It's less than that. So we just don't know again. And the reason, just so people understand why we're doing it this way, why are we doing it by the river, is because what we're minimizing is we know that water lies flat. So everyone moved all of their experiments, line of sight experiments, laser experiments to water. But a lot of them did it at the ocean, where you get a lot of atmospheric lensing, etc. And what's happening here is we are doing it with the water. The water is our baseline. The water is our level. And we're doing it for this long stretch, but we're doing it at a time when there should not be heavy refraction. You're not looking over water. You would be looking over water when you came to the other side and looked across, but you saw that the distance is right there. It's not even far. So what we're going to do on this side here is, once we have those posts, and let's say we're done with the laser experiment, if I can get a second laser, and I got to talk to Bob and see if he'll let me borrow his, but what we want to do is set up one laser here at the post. Let's say we measure 2 feet. It would be nice if we can measure from the water to here. So basically somebody's on the other side with the theodolite, looks across, tells us where to level off the laser. Okay, boom, we have it. He has the distance between here and here, let's say, is 3 feet. Okay, great. Now we go over here to this 2 mile post, and we do the same thing heading back this way. And again, the theodolite comes over, aims it, and tells us, okay, where. But we want to go, this time, we're going to go 6 inches higher. Okay? So now we've got laser here, this laser 6 inches higher than this laser. Okay? When we shoot off the laser beams, what should we see? So this laser beam shoots off this way, and what we should see is it should hit higher on this post. Not 6 inches, but in 2 miles, it's 32 inches. So you're talking almost 3 feet higher, meaning we move this laser up 6 inches. Well, it still has to make up another 26 inches higher than that. And then you take this laser and you shoot it right back. And again, we're leveling these. So you level them. And we've got digital levels. They're little cheap digital levels, but at least we can have them digitally done. And then this post shoots off. Where should it hit? It should hit here. And again, it should hit 26 inches above this telescope or thereabouts. So this is what we should see if we live on a ball. And there is no argument from a baller or a flat earther that really refutes this, because it has to be. So what I think we're going to see, well, I think what we see would be quite simple. what we're going to see is oops, too far. We're going to see this laser shoot across and hit here. And we're going to see, go down. And we're going to see this laser shoot across and hit here. And at that point, how can you claim that the Earth is curved? How can you claim that there's 32 inches of drop in 2 miles if we've just showed that by leveling 6 inches above the distance that this one is from the water level and shooting it across, we should see a crisscross of beams? That this beam should hit higher and this beam should hit higher. In which case, again, from this perspective, what you'd be proving is that the water is higher in the middle, because we know that this would be the same distance here, which would mean the water has to be going, bad color, the water has to be going like this, in which case water would be going down this way and this way. And this is why the experiments aren't really needed. I mean, if you can think and you can rationalize things without holding Neil deGrasse Tyson's hand through it all, you will see that you've been lied to. That it is absolutely impossible for you to live on a ball. Hate to tell you, love to tell you, whatever you want to say. I wish it were true that we lived on a ball. It's what I was taught. It's what I grew up believing. And hey, who can say that we didn't think space was kind of cool? You know, they sold us something cool. My wife gets mad when I say they sold us. They forced us. We didn't buy anything. They forced us to believe in the idea of space and these planets. But really now when you look at it and think back, you're like, man, what a joke that was. Places you'll never go. I mean, that's what we have. We have a world full of people championing for and being crowd fans for and you know, about something they'll never see and somewhere they'll never go. So, you know, the human race is pretty manipulable when it comes to anything that they want the masses to believe. They could literally say anything on CNN and it would be the talk of the world tomorrow. They could literally make up any story that they wanted, and at every water cooler tomorrow it would be the fact of the day. And that's sad that it ever got to that point. Once the United States knew the power of the media, they took over every facet of it, and everything you get from mainstream audiences is totally contrived. And how pathetic it is that there's people out there claiming people like us are doing the same thing. I mean, it's absolutely a joke that it's the biggest disgrace to mankind what happened to our media, the way that they operate themselves now, the way that they aren't even giving their real opinions. People have complained about Truth Frequency Radio before because I'm on Truth Frequency Radio and Zach Hubbard's on Truth Frequency Radio. And people have called Chris Geo, the owner, and said, you're called Truth Frequency Radio, yet you have a flat earther on one day. 2 days later, you have somebody who's staunchly against it. And Chris's answer is perfect. The reason it's called Truth Frequency Radio is because both Zach Hubbard and myself are telling the truth about our opinions. We are not paid by anybody to repeat what they tell us to say. I'm not paid by anybody that says, you have to say this, Jaron, you're not allowed to talk about this, you can't talk about the Jews, don't you question the Holocaust, don't you ever, nothing. I have complete control over everything, every word that comes out of my mouth. I don't have to worry about anything I say because I have complete control. That is so far beyond what you get from talking heads who appear on TV every night at 10 o'clock and read from a teleprompter and say the same words that they were told to say. And yet people don't see that. They want to turn and say, oh, you truthers are all shills. You're all working for... It's a completely different thing. Totally different, because you should recognize when somebody is telling you the truth. You should recognize when somebody's speaking things from their heart, that they believe, that they're not just making up. People don't use their real name and just make shit up because it's going to come back to haunt them. Yet, if you watched Globebusters yesterday, you know, you've got people like Soundly who wants to come and make fun of flat earthers or wants to come and show us proof that the theory or the model of the ball earth is so right, but is afraid to use his real name, is afraid to use his real Skype. And you've got people like me that this is my real name. My name is Jaron Campanella. That's it. It's never been anything else. And I'm doing it with the full knowledge that I will be responsible for every word that comes out of my mouth forever. And so that's a big difference than a Red's rhetoric who will go around calling everybody every name in the book, but has nothing to hold up to it. If he finds out that the earth is flat tomorrow, the man will disappear, probably to kill himself in some cave, but he will disappear from YouTube, and then he is not held responsible for anything he ever said, anything he's ever done. goes right out the door. Nobody cares. That's a different thing for Bob, myself, Dave Weiss. These people are using their real identities. This is us. And we are so sure about what we're saying, we don't have a problem with saying it. And again, I've said this 1,000 times, it doesn't matter if we are wrong. If we turn out to be wrong, what we have done is we will have proven that what we were taught is the truth. Now, I think that's the farthest thing from the truth because I've already seen that. But in theory, there's nothing wrong with questioning authority. There's nothing wrong with, because all you're going to do is you're going to get to the bottom of it. You're either going to come out the other side like, yep, we were taught the truth, or you're going to come out the other side with, we've all been deceived. And I don't think there's anything wrong with that. And the alternative to that is to be like a fanboy who just says, nope, if NASA said they did it, they did it. Well, how exactly did they do it on the moon with nope, they did it. They had to do it. There's no way they couldn't have. When the evidence tells you the opposite. It's pretty sad. So we want to do this experiment too. I have to get the second laser. It is possible that we do this with one laser, which is kind of what I think will end up, or what I was planning on doing. Meaning, if you still do the measurement, you shoot this one, mark where it hits, and mark where it was, and then you move the laser. You don't need them shot at the same time. Then you bring the laser over here, do the opposite, and then mark and mark. You should be able to have the same results. And again, it's not a crowd-funded experiment. It is an experiment that is not going to cost me more than $400 plus gas. So it's something that we'll be taking care of. And if people have a problem with that and say, oh, you messed this up or you messed that up, then go do it yourself. Because what I'm doing is trying to do it the best I can. That's why I'm putting out this video in a day or two, asking people their opinion of the experiment. Because if there is a flaw in it, if a baller says, well, no, you didn't take this into account, you didn't take that, then I need to relook at it, because I don't want to find some of these things out after if I could have known them before. And so I want to get kind of feedback on that. And there'll be a lot of complaints that I don't think are correct or are applicable. But the good thing is that I feel like I'm capable of deciphering that. So I'm going to look at them and decide it's really for my own use as to, am I missing something? Is somebody going to come up with something that I didn't think of? That's why I put it out there. And I think walking away from this, again, I don't even think there's any chance that this video will be the end-all be-all, because if I do have some sort of proof, if it does appear that what's happening, then the next time we go out there, we have a TV crew and we call the news and we call the media to come out and watch this experiment, because we're going to know what it's going to show. And so that's something I don't think we've been in a position to do yet. And then we have a film crew, and we pay for filming it to where it can be like a documentary or something. I don't know. These are things that we've got to look at. It's not as easy as everybody thinks. Just getting people on board with it is the biggest deception of all time. It is a huge thing, and it's going to take, I certainly see it happening, that it will come out. What it's going to take is a systemized process, kind of like this, to where we do a test, we notice that it proves it, and then we start doing it correctly, honing in on it, and then people all over the world can find locations around them that do this same exact thing. A 3-mile stretch of water is not that hard to find. And doing a test that costs $400 is not that much to do. Another thing I want to do, and I'm going to talk about this in an upcoming video as well, but I'm going to start, when I'm not using something that we've gotten basically through Patreon, or the laser I bought myself, but technically you could say that's from Patreon. And going forward, as we buy things, I want to have them available to loan out. So if people want to, if I'm not using my laser, then there's no reason why it should not be in use by somebody who wants to test some facet with the laser. So we don't know how we're going to do that yet. I don't know how I want to do, if somebody has to submit to me an idea and then I decide, I don't know. But that's something that I think would be cool, is if we have all these things that we start buying for whatever reason, and if people want to use them, then we can mail them the laser, or mail them these levels or gyro or whatever we have, and then they can use them and then send them back. And then it's kind of like a community thing, to where maybe somebody has a good idea for an experiment, but they need a laser, and that's, I think the laser we have is something like $350. So it should be not just stored behind me like it is now and rarely used, it should be out there and available for people to use if they've got an experiment they want to do and they don't want to ruin my laser. So that's something we want to look at in the future too. Let me move on. Was there something else I was going to cover? I probably am not going to cover it this time. So next time I will also do I want to cover the Redstone Arsenal over there in Alabama. Pretty interesting story with that goes. And I'm writing this down as I speak so I can remember. Because I want to go to Google Earth and let's see, Google Earth. Do you see that or no? No, you don't. So we're going back to Google Earth real quick and just show you what is it called? Marshall Space Flight Center, I think. Marshall Space. This is just kind of a teaser. This is my teaser. Marshall Space Flight Center, Huntsville. There we go. Okay, so when we go to Huntsville, and I was going to cover this as part of space and other junk, not sex junk, space junk. No Bill Nye songs, no cis males here. Let's see here. Okay, so this is the Huntsville NASA Center here. You'll see it is heavily guarded. Where I lost my place. Where are we at here? Isn't this where, and then the river's down here, or am I backwards? Let me see which way I'm looking. So I can get my bearings. And that's there. Okay, so it's this way. So in Huntsville, that's crazy because it was basically a chemical warhead or chemical warfare manufacturing plant in the Second World War. So you've got all these things over here, like all these underground bunkers, lots of interesting stuff out here. But one of the things that is interesting is all these buildings are just numbered. You know, this building's 4205. This building is 4202. So you don't get any information about any of these buildings. This right here is this is the entrance here. Highly, highly protected. You'll see as you come in here, you've got this station, armed guards, people. You got to cross this second station here. A lot of people work out here, and everybody who works out here lives out here. So a lot of people say, well, wouldn't somebody, if they knew something, wouldn't they say something? What about whistleblowers? Well, when you're given a house and you get to live with, all these people that are also, and I don't think even most of them know that it's compartmentalized. But if they did know, maybe they're just quiet. These are all underground bunkers, all throughout this land here, all underground shelters. Who knows what's going on in them now? There is cars outside of them sometimes, so stuff is being held into there or whatever. Tons of it. It goes on and on throughout this land. You get over here, look at all these underground bunkers, underground bunkers, underground bunkers, and throughout this whole land, there's a ton of it. This is a huge piece of property. And over here at the Marshall Space Flight Center, watch this, is pretty funny. If you type in International Space Station, and you double click on this, International Space Station, well, it takes you to Huntsville, Alabama. This is the International Space Station Payload Operations Center. So certainly not saying that they're here, but if they are, they're probably underground. So go look for them there. So interesting that. And then also, if you've ever done the street level view of the ISS, this is where it is. And they try and pretend as if they did it from space. But clearly it is a walkthrough of the fake one. And I was going to show a video on that. Do I still have it up? Yeah, let me show you this video real quick so you can see what I'm talking about. Maybe I will cover this if I can get it done in 10 minutes. Let me show you this real quick. Pass this one on and this. So let's watch this video here.
The sheer size of the space station, it's huge, it's unbelievably big. So I wish people could see it with their own eyes. But that's why in the future we'll hope to make it more accessible with projects like Google Street View.
We've mapped all over the world, and we really wanted to see where we could go, and why not space?
Well, because you can't go there.
What we're doing here is...
So what we're doing here, notice, again, look at this control center here. This stuff to me is just so obvious. If you have a space station and people live their lives in it, then you don't need to have this station here where basically everything is run through a testing. Well, this is all the cameras that we see from. You wouldn't need to do that. But yet they do it. They care more about the video. They care about what comes out to the people. They don't care about any science going on.
We're going to try to bring Street View to the space station.
Okay, they're going to try and bring Street View to the space station. Let's see. Oops, didn't mean to do that. I messed that one up. Where was I? Right about there. Is this guy crying?
What we're doing here is we're going to try to bring Street View to the space station.
We have to do the best work we can all together as a team, but it's not only us, it's also the team on the ground.
Everybody works together to get all the right stuff at the right time.
Okay, this guy is holding a camera, turning in a 360 to get a street view of the ISS from the ground. So these people are taping
the Street View collection will bring to people the wonders of science and engineering and what it takes for people to go all the way up to space and look down back to us.
Okay. Do you want to see the first pictures?
Yeah, that would be great.
So he said, do you want to see the first pictures? And what is that? Anybody see what that was?
Whoa.
Whoa.
I think it's amazing. It's so groundbreaking.
It's only through international cooperation that you can do this. And all the results we're getting, we're sending them back, and we're hoping to make the world a better place. And that's why we're here, and that's why it's important. I'm very enthusiastic about bringing Google Street View on board the ISS. It will be a fantastic opportunity for everyone to fly with us and to experience the incredible feeling of being in space. So see you soon on board the International Space Station.
So I did a little video here where I was basically, and the thing was stuck for some reason. I've done it before, but this thing would not let me leave the cupola for some reason. But I was just kind of looking around in here, and if you haven't done this before, you'll notice that the lines don't line up. Where did I show that here? Back a little bit. As you go around, I mean, they don't. It's not even filmed correctly. I mean, if you look at this, supposedly this is the blue atmosphere of Earth. I mean, come on, give me a break. And look at over here. Oops. So we have a little stair step, and now we go to a different stair step. This is not. These windows are curved, if anything, and if it is up there, it is a high altitude plane, and the windows are curved, which is so clear. In fact, those guys will even tell you that from where they're at, they say they can't see the whole Earth, yet these windows allow them to, because the windows are a cupola, meaning there's a center window and then angled side windows, which are going to give the appearance of a ball. So for all I know, they're even fooling these astronauts. But I really, the reason I don't believe anybody's up there is because I don't think anybody gets in a rocket and goes to space. I don't think it's possible. I don't think anybody does that. So we've never seen a video like of somebody holding a webcam, somebody holding a GoPro out the window. You've seen those rocket launches. Every Soyuz launches, and they've got a window right to the right of them. Tell Tim Peake or one of these clowns to take a GoPro camera and just hold it to the window. So we know you're going to space. You can turn it and smile and then turn it back out the window. Whatever. They've never done anything like that. No helmet cams on astronauts. It just happens that they, once they're in the pool, then they'll turn on their helmet cams and allow you to watch them swim around. So anyway, I was just kind of looking at this thing, but it wouldn't let me leave this room, which I'd done before. Like here, I was trying to get out, and no matter what I did, it had me stuck. So we will see real quick if I can get in there now. Let's go back to Google Earth. Oops, I need to bring you with me. And that's another thing I need to learn to do. I think that there is a way to make it so that the OBS goes with me rather than me have to tell it to, but it's a learning process. So in here, if you can find the ISS and Street View, and I think you have to be on the online one. Let me go do that in the browser instead, because I think that the browser one's the only one that has the little pictures that come up at the bottom. Let's transition to the browser. And there we go. Alright, so I'm going to see if I can get the Street View. So I think if we go ISS Street View, we can probably get there, and I'll show you some things that prove that it was taken from the ground, not from space. Let's see. Oops, I probably should have gone to a link that Center is orbiting complex space station infographic. Where's the link? The entire blog post here. Street view here. Hopefully it doesn't get me. I did this yesterday and I was stuck. I couldn't get out of the cupola. Hopefully it doesn't do it again. Nope, this one works. Okay. So in this supposedly is this is the ISS, right? So we're in here. See, there's a little toilet, and these are all their little segments. And you turn around like this, and supposedly this camera is being used in space. So if we look at these different little modules down here, and why won't it let me look at these? Hopefully you're seeing the same thing I am. Yes. 1 second, I'm trying to figure out why this little thing. Oh, you pop that up. Okay, and let me find the one. Let's see. I thought it was this one. Maybe it's this one. And let me find it. So in one of these, and unless they got rid of it, but good thing is I did record it. I have it recorded somewhere. In one of these, you can see out the door into the Marshall Space Flight Center. But let me find which one it is. And you should be able. Can you move through these? Let me see here. Okay, cool. I'll find it this way, because when you get to the end of it, you can see outside. Let me find where the end of it is. I don't remember which way I'm going. This way? This way? Okay. 1 second, I've got to find the... I know what the room looks like when I get there. That's interesting. What are these? So I love researching while I'm on live. I don't know what those are. Just never seen TV screens there. Let me find where this is here. This does not look like it. They should have like a little map down here so you can see what the room you're in or whatever. I don't see... Stop in the middle here. Oops. Let me go this way because I'm not turning right. Let's see. Where is it? This one? And then that one. What's this room? It's real scientific though, isn't it? Nice and cleanly in here. I remember what it looked like. Let's see here. This way. And this way. Nope. See, I don't know why it won't let me go through there. Let's try this again. It's this one. SpaceX dockings, Veta, Columbus Research, Japanese experiment. Is it this one? Trying to find the room. See, I keep getting stuck in these loops. I don't know how you go to the middle. What's that? Great. Nope. Let me try again. It actually looks a little bit different, but I think it's the same one. There's the cupola, and then there's this one. I remember being here. Let me try this one. And then you go in here. I know you can go out. This is the crew lock where they supposedly go out. And then we come back. Missa! Come here for a sec. You have a better memory than me. I said you have a better memory than me. So I'm looking at the ISS. Remember when we saw you could see outside? Where were we? What?
I have no idea what second.
Does any of these look familiar? Remember it was like looking out to the left. There's the little... Unless they changed, but the good thing I did record. I just don't know where that's at.
I think you recorded it.
Yeah, I recorded it. I'd have to go find
There's
where...
that room, but the scuba tanks aren't in there. Right?
See? I think it changed too, huh?
Oh, they're still in there.
Oh, they're still in there. Yeah, these are their scuba tanks. So I remember we moved off of this room. It was like out here into the left or something. But it's like not letting me go. It like sends you to a different section now. Clear up. It was like right. That's the cupola? It's going to let you go where it says it's going to go. I don't know if it's different. I remember what that room looked like though. It was, you could tell it was like where they walk in. Remember there was papers on the wall?
Yeah, it was definitely not the ISS. It was,
It's the one on the floor, on the ground. Let's see here.
I thought it was like almost like, not saying it was a secret door, but it was almost like a...
We didn't get there this way. We were doing it by swimming around, if you will.
Yeah.
Maybe it was here. Did we go through this thing?
I'm sorry, I don't remember.
I thought she had a better memory than me.
Well, not when it comes to like. I don't really.
You just you remember that we.
I remember seeing it.
Seeing
for
it.
Sure.
Let me
And
find
I remember
it.
being in where, Kentucky or something.
Alabama. It's that Marshall Space Flight Center thing. So I just don't remember where that room was. So I'm just gonna keep looking for a minute here. See if I can find it.
Look at all the science.
And I might look for the video in a second if I can't, because I should be able to find that.
There's so much science going on in there.
Tons of science. I actually saw a report of how many hours of research that they said they did, and they said since it's been up there, they've done 6,000 hours of scientific research. That's nothing. I figured it out with, with
18 years, right?
So yeah, 17 years, and then if you figure out even like I think I did it at 4 hours a day of work time for 3 astronauts, and even that would be like 15,000 hours. So they've done like 1 hour of work a day for one person. So let me find this here. I'm trying to see if any of these look familiar. Maybe this one. This kind of looks like it, but nope. I might have to go after the video, because in the video maybe that's even good because it'll show that they changed this. Wait, maybe that looks like it down here.
There's like a side door, maybe. From what I remember. I don't know. You can get turned around so quickly.
I know, it was a side door. It was like this, but then you could go here and you could see out. It was kind of like this. It might even be this room. But this door was open and you could see out to where people were working. I'll have to show you the other one.
Like there were handrails.
Yeah, there was like handrails. It was like for.
Go downstairs, yeah.
It was clearly the. And I guess we should have thought. That's why I did the video though, because in case they saw that and then changed it.
That's
So.
a good lesson.
I'm gonna. Yeah, it's a good lesson. I'm gonna look for another minute here, and if I don't find it, I'm gonna go get the video, and show that, so that then you'll see that they changed it. Because I don't recognize these rooms. What is that?
It's a flashlight.
Looks like a prop. Doesn't look real. Did you see these? I don't remember seeing these last time. Look at these two cameras.
Weird.
Like,
Blue and pink. Okay.
very weird. But I don't see the room now. Not the room that I.
You have to have security cameras, on the ISS. You never know who's going to be barging in on you.
Aliens could show up at any time. That light looks like it's outside. It's like windows, just to like. Outside.
Not in space.
I don't know what that is. None of these rooms look like that one, though. I remember there was like a piece of paper on the wall. It was almost like where you would come in.
Mm-hmm.
But I don't see it. Let me just check these ones. So we went. For sure we saw that one. We saw that one. Did we go here? What is all this? It's so ridiculous. See, and it gets you like, why can't I leave here? Don't even let me leave. It's great. Just get stuck in rooms.
I would get so claustrophobic.
Oh man, I'm already claustrophobic. So we went to that one. That's a big tunnel. Permanent multi-purpose module. Don't recognize this one either. Oh, we were in his first place I was. Okay, so let's try again. So we got that one. I know it's not the Japanese one. We did that one. We looked at that one. Looked at that one. Didn't go to the SpaceX. No, we were just in that one. And this one. God, that'd be so claustrophobic. Look at they talk about it being a street view, but I can't leave here. They've trapped me. Like, why can't I go through there and make a left? Alright, I'm going to look for that video. Let me see if I can find something for you to watch. In the meantime, Miss will sing for you.
No.
What? Why not? I'll sing then, I guess. If I have to. Alright, turn one more. This one. And this is the scuba tanks.
I'll play the ukulele. No, just kidding.
That's weird. See that camera right there?
Yep.
Yeah, let me get the video, because the video showed that this is much different. And I'll just have to estimate the amount of time that... where's this? Weird.
Why is there an oriental rug right outside of it?
Don't say Oriental.
Oh.
It's racist.
I'm allowed to.
This is where they pee.
Or drink.
Good one.
Thank you.
Okay, I don't see it. Alright, let me go find the video. What do you people want to watch? Let's see here. Do I have anything here? You could read about Redstone Arsenal. You can read about... This is interesting. This is Project Horizon. I don't know if you've ever heard of that. That's the moon base that was supposed to be done by December 1966. Interesting story there. Let me see if I can find a video for you to watch while I look for this one. Let's go to... I closed this down, didn't I? Okay, 1 second. And what time is it? 5:10? I gotta be done by 5:30. So let me find this video. So I'm just gonna leave that screen up for a second while I find this video. You can talk amongst yourselves. I'll give you a topic. Jaren not being able to find this video. Discuss. Luckily, I've got a pretty good organization skills, if you want to call them that. But I have to remember the date because they're organized by date. So give me a minute here. It would definitely be here. And let me organize by date and type. And it would be under recording. Okay, so I should find it now easily because I just have to now remember if it was before or after I recorded something else. It was definitely before that. It was before that. 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 This one is, oh, that's today. So you go this way. It's before that, before that. Maybe this one? No, that's the live ISS feed. That's that one, that's that guy. No. No, before that. Gosh, how long ago was it? It was probably right around this time. Would it be around right here? Sorry for the dead time. I want to not end the video without showing this though. So give me a second. And share videos. Wouldn't be in clips. Clips. That one. Times ISS. Oh, I know where to go. I'm just going to go to Screencast-O-Matic and look at all my recordings there. That'll be easier. Let's see if we can find it in there. Let's see your Screencast-O-Matic. Yeah, the good thing about Screencast-O-Matic is they keep all your screen recordings. As long as you remember, it had to be maybe a month ago, or maybe 2 months ago. Let's see, log in. Because I don't know what the excuse would be for why it has changed, other than they got rid of the one that showed that they were on the ground. Okay. What happened here? Didn't I just... What? How did I end up here? That was weird. Screencast. up here, and log in. All right, and browse recordings. No, I said browse recordings, don't launch recorder. Can you browse recording? Thanks you. Alright, let's see. It's going to be... I'm going to have to be able to see. So that was the eclipse. This shows 13 in August. What's this one? Let me try this one. You might hear some noises. I'm trying to find it. Oh no, this is the Coliseum. It was before that. So it must have been July. Oops. Is this it? Maybe I found it. No, this is about the eclipse. It was before that. Nope, not this one. I say I have a good organization, but it's probably easier if I just named them. But this is South Pole. Okay, it was before. What's this one maybe? What's this? It's Antarctica. Nope. And before that, Antarctica is right around the same time though. We're right in the right spot now. Antarctica. Nope. And this one. ISS. This might be it. I'm at a virtual tour of the ISS. Was that the same day? Oh, I'm checking this video to make sure it's not in this video somewhere. This one's long. But that's just a virtual tour. There's a site that I found that you can actually supposedly do this virtual tour of the ISS. It would have been around this time though. Come on, show yourself. So we'll go back. And what's the next one? Go, oops. Go back. So that's 230. 189 is what? Play. Again, we're showing the ISS. This is 35 minutes. I think this was the same day. Come on. Now we're showing Dwayne Kellum's video footage. Why would I screen recorded that? And then this one. Showing Skype calls. I know I wouldn't have moved it. Okay, this one. More South Pole. Nope. Let's keep going. This guy, remember this whole video was about him and that. Okay, that wasn't that one. Where did I go? Hold on, June. Nope, this one, show all 13. This one? I feel like I'm in the right spot now. This is also where that lady wrote on Quora that she was unhappy with her students for watching jeranism videos and telling her that she was wrong about the shape of the Earth. That's pretty classic. And this is a screen cap of Slice Barcane. This one, 1301, 1386. What's this one? Gun safety. God, I thought it was after this one. So that's this. Recording 172. Couldn't have been in May. There's no way. Hold on here. Nope, that's... Oh wait, maybe it's... Man, I would be livid if I cannot find this. It would have been around this time, though. That's showing our store. Oh, wait. No. What's this next one? Recording 184. Just did that one. Recording 185. See, I'm already back to where I was doing like the Southern Star Trails, or the whole Star Trails thing. That just seems like it went too far. Okay, this is where Neil deGrasse is saying that universe under no obligation. It wouldn't have been that time. And the one after that, Star Trails again. And the one after that is air flights. Okay, so I remember which video I was doing at the time. This is the video where I told Neil deGrasse to find a plane, go across the South Pole. So it wasn't, let me scroll 10 from this date. Okay, so that's all those. And then these ones. Recording ones. What's this one? 21 minutes. Annual view of pricing subscriptions. Neil deGrasse Tyson site. And now I'm like going back to things I forgot. So it's definitely for these. Okay, this is the wrong month. So it's not in May. So it's got to be June or July. So this one here. I remember that one. Recording 188. Nope, this is still false flag stuff. 186 here. 23 executive order. Nope, false flag stuff. This one here. That's South Pole, South Pole. South Pole, what's this one? Nope. And then this one. Nope. Whoops. I'm gonna find it. I'm determined. What time is it? I got time. It's gotta be sitting here somewhere. I wouldn't have moved it. Could it have been at the beginning of August? I don't think so. Nope. This is when I was doing all the stuff about Transglobe Expedition. It's going to be before that. Sir Ranulf, before that. This is, what's this again? That was the Roman Colosseum. That's had to be before that. Show all 13. What is this one? Filmora. Why do I have Filmora? Filmora. What is this? Interesting. No. This one, maybe this is Mars. Curiosity rover. Satellites. Philae lander. I feel like I'm in the right spot here now. Oh wait, move this one. Nope, that's only 3 minutes. It had to be longer than that. Nope. The only thing I could think of is, no, I wouldn't have taken images. Well, maybe I did, but nope. This is universe. Nope. This one, Transglobe Expedition. Nope. Oops. Nope. This one is Sir Ranulf Fiennes. I do kind of remember I was reading something and no, wait. It's all coming back to me now. I remember I was on Twitter. Have I seen anything that's Twitter related? Okay, nope. So it's got to be in July then. All right. I settled down to 1 month. It was in July. And it was, this one it can't be. That's, this says 7/17. Shows Universe Sandbox. Nothing there. And this is definitely not it. It's 9/17. South Pole, not it. South Pole, not it. South Pole. It's 31/28. This is maybe it. Nope. let's see here. So this is, now I'm on Twitter. Let you explore space station. Now it's a virtual walkthrough. It's a new level virtual. Okay, so I remember doing this. It might have been that one video I found earlier then. This one here. This is the virtual ISS tour. And we're going on that. This video is long. This is 2 hours, so I'm having to skip ahead to see if it's in here. Sometimes I just go on these binges where I'll just record what I'm doing for a long time. So I'm just making sure it's not in any of these. And then I share a link with your, nope, I remember that. Call that Summer's Gate. Okay. So if it's not that one, this one's 35 minutes. Showing the ISS. So this is showing the tracker. Oh wait, ISS. Nope, that's not it. Live view. That's showing my site. Okay, then there's this one. ISS, the purple camera. What about a Google Earth view? This one here. Which video is this? Oh, this is Wayne Kellum's. This one. If I've looked at all these, this is all that. Skype calls. This is the South Pole. Nope. That guy was on that one. This is Cora talking about the teacher. Okay, that's not it. And this one is, nope, that's just a little section. Man, June doesn't seem like it's the right month either. It had to be in July, I would think. Man, I do not remember what I did with it for recording 179. Let me check a couple more here just to make sure. Brian Cox. And that seems so long ago. Wasn't that long ago. Couldn't have been in May. This one says orbit. Nope. These seem so long ago. There's no way. So it had to be in July. Nope, not that one either. And then April, certainly not. Now I remember these ones, okay. And this one, nope. Alright, so it had to be this one, in July, or in June. Any of these look familiar. Recording one, it couldn't have been 153, it wasn't 208. It was much longer because I remember going through a couple different segments. Had to be at least 5 minutes. This is Sandy Hook stuff. I could have sworn it was after the Sandy Hook stuff. Alright, so that's going to go this way. That's the stars. Wouldn't have been then. That's wouldn't have been then. Wouldn't have been then. Wouldn't have been then. Not that one. 188. Nope. That is the still in Sandy Hook. Yep. And 197. Nope, that's Gabrielle Giffords. Sandy Hook teacher. A lot of Wayback Machine, not that one. The gun safety, so this was all Gabrielle Giffords. Yep, not that one. And we already looked at this one. Okay, so it had to be then in July. And the first one, no, that's Slice Parking. No, we looked at that one. Maybe it is this one. ISS. Just going to skip through a little bit slower on these. There's a couple that are ISS footage, but they're seem like they're just all that. Okay, then we go to Twitter. That's kind of what I remember. There's a glacier picture, glacier video, Summer's Gate. Wait. ISS 3D visualization. Virtual tour of the space station. ISS.